What's up, everybody? This is Danny Mathematics here again with another example to explore. And today, guys, I want to go over example 4 and example 5 of how we're going to figure out the domain of a function and a range of a function, okay? The domain of a function and the range of a function, right? And remember, guys, just like I've stated in example 1 and example 2 and 3, the domain is the horizontal boundary of the function, okay? So the domain is how wide the function can actually expand, okay? So once again, the domain is the horizontal boundary of the function, right? Which represents the values of x because the x-axis is the horizontal axis, right? So as we expand, the x values are also expanding as well, okay? The range is the vertical boundary of the function, right? How high or how low a function can actually expand, okay? So it's actually the vertical boundary of a function, and the domain is the horizontal boundary of the function, right? So remember, guys, the domain is based on the value of x, whatever value or values x could possibly be, okay? And remember, the range is based on the potential values or the possible values of y, what y could actually be within this particular function, okay? And also, guys, I've already put this hint. Whenever a function has an arrow, this arrow means that this function is continuous. The function is continuous, so it's actually going to continue to go, right? And it's going to go all the way to infinity, whether we're talking about the domain on this side or actually the range on that side, okay? Which we'll get to that. But remember, whenever you see an arrow like this, that means that the function is continuous. That means that it's going to continue on, okay? So now let's go ahead and start off with the domain. So I'm going to figure out, guys, what is the least x value x could possibly be within this function. So as I move it over, guys, I have to stop at -30. X is -30. So I'm going to draw a boundary right here to actually show you that, guys. So it's showing, guys, that x could actually equal 30. X could actually equal -30. It could actually equal -30, but it can also be all of these values that are greater than -30. So with that being said, x is greater than or equal to -30. X is greater than or equal to -30, because it can actually be -30. That's why you see this closed dot, but it can also be all of these other values that are greater than -30, right? Which is along the x-axis. It's along the x-axis, okay? Now, as we go along the x-axis, and remember I talked about this arrow, which means that it's continuous. That means that it's going to continue to expand going this way, right? So that means that x could be any value that's less than infinity, okay? Because this particular function can expand all the way to infinity when it comes to the x-axis, okay? So this is our domain, guys, right? And remember, this particular sign means that x is greater than or equal to -30, right? So once again, it's saying that it's greater than or equal, okay? And then when it comes to infinity, it only can be less than infinity, right? Because to be honest, guys, infinity is really not a real number. Infinity just means that the number can keep going up and up and up and up and up, which is forever, right? That's all infinity means. It means a number can keep growing forever, all right? Now, let's talk about the vertical boundary, which is the range. Let's talk about the vertical boundaries, right? I want to know, guys, how low or what is the lowest y value that y could possibly be, right? Or what is the lowest point of the function, okay? Now, as we can see, guys, the lowest point of the function, I know it's not perfect, but as you can see, the lowest point of the function is at y equals -50, okay? Y equals -50, right? That is the lowest point. So if that's the lowest point and y can actually be negative 50, that's why you see this black dot right there, right? What it's saying is y is greater than or equal to negative 50. So that means that y can either be negative 50, or as you can see, this is the lowest point, so it could be any point that's above negative 50. We know that, right? Now, let's move over. Remember, this is continuous. So as the x values continue to be plotted, as this function continues, it also continues up. Because as it goes this way, to the right, it's also continuing up, right? And if it continues up, that means that y can go all the way to infinity. So that means that y is less than infinity. Okay? Because, remember guys, infinity means that the function is continuous. So I just want to write continuous under infinity. Negative infinity or positive infinity means continuous, right? We know that. All right? It starts here. The function starts here, but as it continues to flow, it's going to continue as we move to the right of the x-axis. As we continue to move right of the x-axis, it's going to continue to go, and it's going to continue to go up like that. So we're still going to the right or expanding horizontally, but we're also expanding vertically, okay? So these are my boundaries. Once again, the domain is x is greater than or equal to negative 30, and x is less than infinity. That's the domain. And then the range, the lowest point of the function is y is greater than or equal to negative 50, and y is less than infinity, okay? So once again, guys, that is the range and the domain of this particular function. All right, now I'm going to move on to example 5, right? Now, if you notice, guys, as we flow through this function, we see those arrows. This arrow over here to the left means that it's continuous, right? So it's going to continue to go this way, okay, and expand to the left. But then also, guys, I see that there's an arrow over here. So that means that it's continuous, right? So as it continues, right, it's going to continue to the right, but as we continue to the right, it's still going to level up, right? Or it's still going to get higher along the y-axis. And over here, as it continues to the left, it's going to get lower on the y-axis, okay? So whenever we have two arrows that are continuous, whether we're going to the left or we're going to the right, that means that the domain and the range are all real numbers. Because look at the domain. Okay? I can continue on, and I can continue to be negative, negative, negative until I become negative infinity, right? So x can be any number that's greater than negative infinity, right? But x can be any number, as we can see, that's less than positive infinity, right? So as we keep going, x is less than positive infinity, right? Or in other words, x can be all real numbers. Okay, so sometimes, guys, you might see the domain expressed like that. When it's from negative infinity to positive infinity, you can say that x is all real numbers. Okay, all real numbers, right? So x can be any of these numbers that are along the x-axis, going way to the negative side and going way to the positive side, okay? Same thing for the range. As we continue on this way, guys, the function is going to continue to drop, right? And as we continue this way, the function is going to continue to rise. So same thing as the domain, the y is all real numbers, okay? The range is all real numbers. The y value can be any number that's along the y-axis, okay? So that's from negative infinity to positive infinity, or you can just write all real numbers. Okay, so either you can write it like this, or you can write it like this, guys. You can put y dot dot, and you can say all real numbers. Okay, so this is the domain, right? The horizontal boundary, which it has no boundaries because it's going to go all the way to negative infinity and positive infinity. So it really has no boundaries because it's continuous. And even for the range, as it continues to expand horizontally, it's going to expand vertically, right? So there's really no boundary, right? That's why I put y can be any or all real numbers and x can be all real numbers. All right, so once again, this is the domain of example 5. And this is the range of example 5. Thank y'all so much, guys, for tuning in. I will talk to you next time. Thank you.